This is a video on the divergence theorem. The question states, evaluate the surface integral over S of f dot n ds, where n is the outward unit normal vector, and f of xyz is the vector field 3x plus yz squared times I plus e to the xz times j plus y plus xz times k, and S is a surface that consists of the hemisphere z equals the square root of 4 minus x squared minus y squared, and the disk z equals 0 under that hemisphere. So let's sketch a picture. Here's the hemisphere of radius 2, and here's the disk z equals 0 in the xy plane. And since we have a surface integral over a closed surface with outward normal vector, we can apply the divergence theorem that states that the surface integral, which is the flux of f dot n ds, is equal to the triple integral over the solid of the divergence of f dv. So let's find the divergence of f. And remember, the divergence of f is the partial derivative of the first component of f with respect to x, and that's 3, plus the partial derivative of the second component of f with respect to y, and this doesn't have any y's, so that's just 0. And then plus the partial derivative of the third component of f with respect to z, and that's equal to x. So the divergence of f is equal to 3 plus x. So we want to find this triple integral, and we have a hemisphere, so it's much easier to use spherical coordinates. So a hemisphere is defined by rho is equal to the radius, which is 2, and then the xy plane is defined by phi is equal to pi over 2. So now I can put all this together and write down that this flux integral is equal to the triple integral. Theta goes all the way around from 0 to 2 pi. Phi goes from 0 to pi over 2. And rho goes from 0 to 2. And then 3 plus x, x in spherical coordinates is rho cosine theta sine of phi. And then dv in spherical coordinates is rho squared times sine of phi, d rho, d phi, d theta. So I integrate that, and I work this out. With a little bit of work, what I ended up getting was that this flux integral, which is the integral over the surface of f dot n ds, is equal to 16 pi. And I'm done with the problem.